Oh, no, I fixed it. I'm wrong. We're 36. Well, good morning. And grab this. Take a peek at our schedule real quick. Right, so we're finishing up chapter 2 for today. Again, we're a little bit off because we didn't have class on Labor Day. So we're going to start everything new Wednesday, finish it up Monday. So we'll talk about Project 1. I wanted to finish talking about Project 1 and be able to talk about it with you folks today instead of posting it. The video recording cut off suddenly, and then I had no power for like a day. That was rough. So we're going to do that today. I'll assign Project 1. It'll be doing 2 weeks from today. So instead of it being from last Wednesday, it'll be from today. We'll probably shift all of them to assign on the Mondays then, just to line that up a little better. And that way we'll have all the lecture time to talk about it. And then we'll pick up chapter 3 Wednesday, finish it on Monday, and again on and on and on as we go. So a couple of people had asked about the quizzes. If it got marked wrong and you don't see why, let me know. Or if it marked you wrong and you like we're close with those short answers, happy to go and fix that. Let's make sure you can see them here. Yeah, so you should be able to see the questions and all the answers. So like it's particular. Just let me know. I'm happy to go in and fix that for you. All right. There it goes. All right, so I'm going to fire up Netbeans here. Give that a minute. We'll do a couple more examples. We got through pretty much all of the chapter content in the recording. I want to go through some more examples, spend some more time looking at them, and then we'll do the project. And then we'll have the rest of the day for lab time. This is actually sit practice. I think everyone got the first assignment in. Working my way through those. Just making sure you can get your little Hello World working. Let's see. Yeah, out of 25 more to look at, or 15 more to look at. So I think we're capped at 25. That should be everybody. Yeah, I think that means knows it's a Monday. There it goes. It's almost there. And then don't forget, all the code is out here on the course GitHub site. All the examples and things are going to be out here. I don't put any attachments in D2L. It's too annoying to have to deal with Java files and downloading them and that sort of thing. So all the previous examples were out here in this chapter 2 project we were working on. So I'll probably start up another one. Just this was getting a little long already, but we can keep that for reference as we look at some of these different things we're looking at, like using else if statements to try and find where does this actually match. So you get this one and only one of these will run. Or our while loops. We'll spend more time doing while loops before we start talking about other types of loops. Sorry, that's kind of small. Let me zoom that. Is that better? Oh, that might be too much. Nope, wrong direction. There. So the while loop, again, will keep us inside of that set of curly braces until this is no longer true, which is a lot of fun. That way we can do something over and over and over until we're ready to be done with it. Close. There. All right, so we'll take a look at the code real quick here from chapter 2. Is that a decent size? All right. Yeah, look at our different operators: equals, not equals, greater than, less than. greater than or equal to, less than or equal to. They all work just the way they do in MacLand for us, except for strings. With strings, you need to compare with the dot equals here. So if you have a string, like a variable that has that string, it's that variable name dot equals the other string. Because the equals operator is not going to check if the two strings have the same contents. What it actually checks behind the scenes is, are the two strings located at the same place in memory? Is all that's going to look at if we use that equals operator. Remember when we asked Java, hey, I want to go store something, it asks the operating system to go give me a piece of memory, chunk of memory, to go store my variable. So that's all it's going to compare for strings. So you can use equals or even the equals ignore case, which is probably most of the time, anytime we're dealing with user input, who knows what users are typing? Some people love to have their caps lock on because they scream at people all day long online. They just leave their caps on. So equals ignore case is probably best anytime we're looking at something that the user has typed in, whether or not it matches what we're expecting. So it's like, is it raining out? Yes or no. We're going to check ignoring case. It equals yes. Maybe they gave me capitals, maybe they didn't, whatever it is. I just don't want to have to worry about that. So then in our if statements here, these are conditional, so that if this is true, this chunk of code runs, and everything inside this set of curly braces is going to run if it's true. And then optionally, you can have this else block and say, okay, well, if it's not true, I want to do this thing instead. So we kind of get this, we get two paths. You get if it's true or if it's not true. And either one of those will run in this case. Now, you don't have to have the else. You're welcome to just have an if statement all by itself, and you'll do something if it's true, and if not, you ignore it, and your code can just keep on going. You can do if, else if, else if, else if, make this chain of these together here, so that we're kind of saying, hey, is this one true? If not, 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 is this one true? On and as many of these as we need, we can throw in here. Right, whatever we need to do. And then if you want, again, you can have that else there. So if none of those ifs are true, this else is. This else will run. So again, the term here is mutually exclusive, right? One and only one of those will run inside of a chain. Now, if we forgot all the else's here, we just had a bunch of ifs, right? Java's fine with this, but the way that we wrote the code here means if you got like 100, it's going to say, okay, you got an A, 100 is more than 90, you got an A minus, 100 is more than 87, you got a B plus, 100 is more than 84. So it doesn't work the way that we have it here because we don't have ranges inside of these if blocks. We only have one check here. So we kind of use those if, else ifs to help build that range out to say, okay, well, if it's not more than 94, is it more than 90? Because I'm never going to check if it's more than 90 if it wasn't more than 94 or greater than or equal to 94, right? So the only time I'm ever going to check to see if you got the A minus is if I know you already didn't have an A. So you kind of see it's going to follow this path here. That's why we don't need to say, hey, is it between 90 and 94? Right? We don't need to check any betweens because we already have it's here, then we get an A. If it's not here, then we're going to check the next one and check the next one and check the next one. With our while loops, again, put something in here. Now, it's possible a while loop never runs. If you guess it the correct time, like on your very first guess, this while loop will never run. So a while loop is considered a pre-test loop. It's going to test this before it runs to see. Now, you're probably going to be inside the loop, right? Maybe you know that we coded in our magic number was 42. So sure, there's a chance. But likely you're going to be inside the loop. And then what we have now, we're going to check two different cases inside the loop. And we only want it to be ifs here. So we kind of went through changing it last in the recording, where we might have said, okay, if it's greater than, if it's less than, or if it's equal to, do three different things. But how it works out is we're not getting outside of the loop until it's equal to. So what I can do is I can say, oh, if you got out of the loop, I know you guessed it correctly. So I don't need to have that check inside of the loop here. I'm only checking if you're less than or if you're greater than inside my loop. Because if you did guess it correctly, my loop will stop running. This will no longer be true because we're saying, hey, if it doesn't equal. So if they are the same, right, not equals is false because they are the same. As soon as this condition is false, when we go to check it, the loop stops running. Does that part make sense? We keep on checking inside. So we'll spend more time with loops. We'll do some fun things with them. And then asking them, hey, do you want to keep on entering values? Now, again, we started that value, this again, like, do you want to enter more things? Do you want to do this again? As yes, or a Y, so that we knew the loop would run once. Right, so we didn't even ask them initially, we set it to yes, so that it will run, and then inside of the loop we say, okay, enter your test scores, and do you have more? Enter your test score, and do you have more? Enter your test score, and do you have more? And just keep on entering. And then we got the average. Okay? We're gonna modify this one a little bit here. We can have a little bit of fun with it. We can also look for the highest test score and the lowest test score. So we're gonna do the inside of here. Now, if I just read off a bunch of numbers, what do you do in your head to figure out which one is the biggest number? And what's that process? What do we think in our heads to see which one is the biggest number? I say 27, 59, 11, 13, 20. What are you doing in your head? Yeah? Yeah, so what are you remembering? Yeah, the highest one. And if I say 100, you say, is that bigger than my current biggest one? So we're going to do that exact same thing in code. So we can check to see if the test score is higher than our highest score or lower than our lowest score. So I'm going to add some new values here. So I'll have an int for lowest test score. Now the funny thing here, because I don't know what actually is the lowest test score, I need to start somewhere that's really high, because I want the first score to be lower than that, probably, to be the new lowest. There's a couple values you can use. If you say integer dot, integer dot, here we go. There's a max value. Will give you the largest value integer possible. This one's great if you want to start with the biggest possible number you could store. Perfect. Now, no one's probably getting a 2 billion on their test, right? It's probably just not happening. So like maybe you could just start at like 100, and that's fine if you know what that possible range is supposed to be. Sure, but if not, we're going to start the lowest at the max, and we're going to start the highest test score at the minimum. Integer dot min value. So that way, the very first score I get is probably going to be bigger than the minimum and less than the maximum. Right? And that idea that the lowest score that I see, I'm going to compare, is it less than my current lowest, or the highest score, is it higher than my current highest? So we'll check in here. After we get the test score, we're going to say if the highest test score is, maybe that's the wrong direction. Maybe we'll check if the test score is greater than the highest test score. Sorry, test score. So if the score I just entered, if it's bigger than the highest score, I now have a new highest test score. Right? Because you entered one that was larger than the minimum value. So the very first one is probably going to be the new highest test score. Great, no problem there. And there's no else here. Right? It's just, if it's bigger, it's the new biggest. That's the only piece we're doing here. And we'll do it again. We'll check if the test score is less than the lowest test score. If you're lower than the lowest, you must be the new lowest. Lowest test score, whoops, test score, keep doing that, equals the test score. Okay, so now we now have the highest and we have the lowest as we're entering the values. So then we can print out the highest score is, and we'll append in here the highest test score, and we'll print the lowest score is plus the lowest score. So if you only enter one test score, it's going to be the highest and the lowest. Sure. All right, yeah, we did some numbers. Enter a number, another number, enter a name. Raining out, yes. All right, enter your percentage score. So like 75. Oh no, okay, we're in another spot. That was the grade, now guess a number, 42, we guessed, okay, now we're entering our test scores. Finally got to this point. So let's do, say, 95. And yes, we have more scores. How about 75? Yes, we have more scores. How about 85? And no, we don't have any more scores. So average is 85, highest is 95, lowest is 75. So as it's going through this loop, we're just checking, did we find a new high or did we find a new low? And there's no else's attached. It's only an if here. And that's okay. That's what we're doing here. Does that part make sense? And so this if check here, this is a Boolean expression. Something has to be true or false for us to decide whether or not we want it to run. All right, and then a couple other things we want to look at. Want to compare, so we did like, hey, if they entered something and it equals a y, sure. So for the project, we're going to ask them to pick from a couple choices and we're going to do something with it. So we'll look at, hey, how I might compare what they've entered to a couple different values, right? So we can say, hey, did they enter this? Was it this word or this word or this word? And if it's none of those, we tell them, well, I don't know what you entered. So we can use that while loop to sort of make sure we're getting input that we expect. So I can have a string for, we'll say, I don't know, favorite color. And we'll just start it off as empty right now. And I'm going to say, okay, I'm only going to let you pick, okay, favorite color is silly. Let's do rock, paper, or scissors. Right? So we're going to say while rock, paper, scissors does not equal rock. That's not going to work for us. If, okay, so if rock, paper, scissors, if that equals ignore case, if it equals rock, then we'll do something. If it doesn't equal rock, let's check, hey, else if, does it equal paper? So if, and if it doesn't equal, oops, that's parentheses here. There we go. Else if it equals scissors. We must have to do something. Why am I getting so many weird parentheses there? All right, and if it's not rock, and it's not paper, it's not scissors, I'm going to have one last else and say, like, do you not know how to play? Play rock, paper, scissors. All right, so, and yeah, we don't need to start it as nothing. We'll just ask them here. So we'll output here. Say, let's play rock, paper, scissors. And then we can use that scanner, right? Or what do we call it? I think we call it keyboard. And get the next line. Whatever they typed in here, we'll grab. And then we'll check. Hey, if it was rock, let's do something. If it was paper, let's do something else. If it was scissors, let's do something else. So what should the computer pick? What should the computer throw? I heard rock. All right, so if we're rock, then we tied. You tie. So if we're paper and they're rock, you win. And if they're scissors and the computer's rock, you lose. Right? Let's see. I think all those kind of match. And otherwise, you don't know how to play. So we can just check in here. Hey, did they enter a rock? Did they enter a paper? Did they enter a scissors? And we'll get one of these conditions. Again, these can be larger. You can put more things inside these code blocks. But it's a quick way for us to compare. Okay, great. And then maybe we'll ask them, hey, do you want to play again? Right? We could put all this inside of a while loop. While play again equals ignore case. All that equals a y. Here's a curly brace. There's an ending curly brace. And it says, oh, I don't know what play again is. So we'll start play again. Starts off as a y. Yes, we want to play again so that my loop will run. We'll tell Java that's a string, sorry. Here's a string for play again. We'll start it off at y. If it equals y, let's do this thing. And usually when you see curly braces, everything should be indented 1 underneath to kind of show that it belongs. It's that visual cue. That's a convention. You'll find anybody everywhere uses it in all languages. Pretty sure. Yeah, I think all languages do that. Just to give whoever's reading the code the cue that, oh, okay, this is like a block that belongs to something. And you'll see real light, I don't know if you can see on the projector, there's a small little line that goes all the way down to show everything that was indented in. Again, just to give you that visual cue. Java could care less, but it's for us so that when we read it, it makes sense for us. All right, and then we need to ask them. So if you have a loop, you want to make sure that whatever you're checking in the loop is going to change. Because if we never change the value of play again, it's an infinite loop. They're playing forever. Right? They have no chance to stop. So then we'll ask them here. Okay, we'll say, all right, well, do you want to play again? So we can change the play again input, or we'll ask them here, right? Do you want to play again? To play again. And again, I always like giving them some sort of prompt like y/n or yes or no or whatever we're asking them to enter, right? And then our play again, input, keyboard, next line. And then we'll get that yes or no. And we keep on going. That make sense? So we could run this, and that should be perfectly fine. There's another way of doing this loop, though. Right? If we don't want to say, hey, play again, and have a separate value for it, we can say, hey, let's play rock, paper, scissors, enter rock, paper, scissors, or quit. Right? And if they enter quit, then we could stop playing. So we could be checking, hey, does the rock, paper, scissors value, as long as it's not quit, let's keep on playing, and they can just enter rock, paper, scissors, rock, paper, scissors, rock, paper, scissors. If they give me quit, then the loop will stop. So just thinking about what's going to be easier for users can be helpful. So let's change this up a little bit here. So we need to move this value. So if I declare this string rock, paper, scissors inside the loop, I can't check this here. I can't say, hey, rock, paper, scissors equals something. It's going to tell me cannot find symbol. Where Java starts at the top and works its way down. So if you want to use a value, you would have to declare it above. Then I can have it inside my loop. So we'll start this rock, paper, scissors thing just as, sure, it doesn't really matter. Anything that's not quit. So then our loop is going to be, as long as it equals quit, I'm going to say it's not equal to quit. Remember the not is the exclamation mark? Did we get into, I think we got into that, right? It's not. Okay, so this is a not equals quit. If it's anything other than quit, we're good to go. We want to be in the loop. If it equals quit, stop. We don't want to play anymore. So we'll ask them. And then I'm going to get rid of that last else. I'm only going to check, hey, is it rock, paper, scissors? Because if they entered quit, I don't want to say, do you not know how to play? We told them to enter quit. Right, so let's play rock, paper, scissors. Rock, paper, scissors, or quit. Be all done playing. I don't know, should we put like quit in like quotes? Is that so you know Q there or something? All right, that's getting a little long here too. I'm going to bump that down a line. Now it's still yelling at me here. It's saying variable rock, paper, scissors is already defined in method main. So if you already told Java it's a string for rock, paper, scissors, you don't need to tell it it's a string again. We can just say, oh, change the value, please. Assign it a new value. Okay, and then if they entered rock, we tie. If they entered paper, we win. If they entered scissors, we lose. And we don't need to ask them if they want to play again or not, because it's just happening. Right, so let's try that. Let's see if we can play rock, paper, scissors. Right, let's give it a bunch of values, get through here. I'll have to actually guess the number. One, no. All right, rock, paper, scissors. So rock. Hey, we tied. Paper. We won. Scissors. We lost. ASDF. Just enter a value. Like it doesn't really give us an error here. We could check if we wanted to say if it have one more, else if it's not quit. Tell them please enter rock, paper, scissors. I guess that's more proper. Well, we can do one more check. So else if it's not quit, we can tell them please enter rock, paper, scissors, or quit. Right? We want to be helpful, right? Because users get confused by our programs all the time, right? they're not programmers. They don't know what's happening. So you need to really guide your users. Give them some helpful hints. All right, there we go. So we have a rock, great. Oh, we already tried that one. ASDF, please enter rock, paper, scissors, or quit. Quit. And it stops. Finally finished. So we were able to do that loop that kept us playing. And this way, I didn't have to enter, yes, I want to play again, or no, I don't want to play again. Right? I can just, as I'm entering rock, paper, scissors, I can say, yes, I want to play, or I want to quit. Just trying to make that one little bit easier for the user to use and to play there. That part making sense? All right, cool. So let's talk about the first project. Let me make sure I'm in the right. Yep. So we fire up project 1 here. Now, I know it's still officially summer, but I'm in the fall mood already, okay? So we're going to talk about making pies, because I'm ready for pie, because it should be fall. We're so close. We're going to pick what kind of pie. We're going to ask the user. We'll ask them. Apple is the best, I agree. But so it'll be due 2 weeks from today at 10 a.m. So the idea is, in class in 2 weeks, I'm going to go over the solution to the project. And once I've done that, I can't take it late. Right? So make sure you're planning ahead accordingly there. So let me enter grade value, project 1. All right. So we're going to write a little Pi helper. Oh, you need that GitHub Classroom. Let me grab that real quick. This will make a new repository. So for the project 0, the Hello World, we had a repository. We're having a new repository. Oh my goodness, I can find it here. For project 1. And of course I named them differently. Sure. That's fine. Here's our link. We're going to submit the URL to the feedback pull request. And then in addition to that, I'd like you to use the rubric I'm going to show in a minute to give yourself a score. So for every point in the rubric, tell me whether or not you got that point. Believe it or not, I've had people, like I go through and I put rubrics out there, and then they say, oh, I don't know how I did. And I say, well, did you do the things on the rubric? And they said, I don't know. And I get really confused. So when you turn in the feedback pull request, you're also going to include a self-assessment using the rubric. Now the problem is there's no like interactive, like you can't click it and it'll tell me. So like I get to click it when I score you. What you just need to do is look at every item and say, yes, I got the point for this, or no, I didn't. And ideally, you're going to say, yes, I got the point for everything. Because if you didn't get something done, you should be asking me what you're stuck on, right? Again, give it a little bit of time. Try at least like a half an hour of trying to get unstuck, but don't wait till the last minute, say, oh, I didn't have a chance to do it, and I don't know what's going on, and I'll just turn in a half-done project. Like that's not fun for anybody, okay? So if you're getting stuck on it, let me know. We have 2 weeks for all of our projects, so there should be time to get it done, and we go from there. All right, so we're going to write a Java application that helps us plan on which pies to make and ingredients to buy for our fall party. Okay? So first, we're going to ask the user for their name. And then in every other prompt, we're going to use the name that they gave us. So we'll say, hey, what's your name? Welcome to our Pi application, whatever, here. And they enter Eric, and then all the other prompts will say, okay, Eric, tell me this. Okay, Eric, tell me this. Eric, tell me this. Right? We want it to like pretend like the computer knows who you are, and we want to be friendly and interactive. So ask the user for name, and we'll use their name in all of the following prompts. Okay, so we're going to ask the user how many guests are coming to their party. Right? Like how many people are you inviting to this fall party, right? And then we'll ask the user how many slices of pie each guest will eat. right? Because some guests will eat like 5 slices of pie. If you invite me to a party, I'm eating all the pie. And some people are probably only have one or like maybe half a slice. I don't know. That's hard if we deal with halves, but you know, that should work. All right, let me pull this up over here. Make sure I'm not forgetting anything. All right. What happened? Okay, that's crazy. It's missing from my other class. Making sure we're doing a similar thing. All right, and then we're going to ask them what type of pie they should make. So we're going to say if you make an apple pie, has 8 slices. Right, for any apple pie, we can cut it into about 8 slices here. A pumpkin pie, you can only do 6 slices. And what about a sweet potato pie? Do you guys like sweet potato pie? I have a really good sweet potato pie recipe. No? Really?
I never had it.
Oh, it's really good. You put a bunch of maple syrup in, so like it's sweet potatoes and maple syrup, and then a little marshmallow on top. All right, so okay, what other pie should we do then? We'll do apple pie with 8 slices, pumpkin pie with 6 slices, and blueberry pie. Blueberry pie. That's 10 slices. Okay, sure, 10 slices. We could do 10 slices out of our blueberry pie. All right, and then we're going to calculate the number of pies we need to bake for all of our guests. Now, sadly, we're not making all 3 different pies. We're picking one, and everybody gets that same pie. Otherwise, it's going to be a little bit confusing. All right, so just the number of pies. Now, it's worth noting here, you can't bake half a pie, right? So if I have like 4 people, and they're all going to have 3 slices, right? 4 people each eating 3 slices is 12 slices of pie. If I make apple pie, right, I need 2 apple pies to give everyone enough, right? I don't need 1.5 apple pies, okay? So we're going to have to do some rounding. They're going to enter it. So yep, just ask them, how many slices are people going to eat? And they'll tell us. So they're entering the value. We're saying how many people are coming and how many slices of pie are they going to eat. So we can do some quick arithmetic. So be sure to value up to the nearest whole number. Okay. You know, we're not even going to do the ingredients. We don't need. Oh, yes, we're picking the pie, so they know to go out and buy the right fruit here. Blueberries? They're not fruit, right? Because they're berries? Or berries are fruit? Is that how that works? They're just like a subfamily of fruit? Okay. Oh, pumpkin's not a fruit, though. Uh-oh. All right, anyway. All right, so let me attach a rubric here. So this is how you get your points. Right, so this is for project 1. So when I go score these, like I'm just going to go through, and if you did the thing, great. You get the points. If you didn't do the thing, you lose the points. Or like if you sort of had it, I try and give you partial points if I can. But
A pumpkin is a fruit.
it is a fruit.
I just Googled it.
The seeds are inside. So like gourds are fruits then, right? But don't they all have the seeds inside? Like they're remember the gourd family or something, aren't they? Pumpkins are fruits? All right.
Mechanically speaking, squash and gourds are fruits because they are part of the flowering plants that contain the seeds.
Yeah, okay. That makes sense.
Did they say that apples were actually vegetables?
I mean, all right, yeah. So technically tomatoes are fruit too. And someone had this great piece of advice, and I don't remember where it came from, but it said, knowledge is knowing that an apple is a fruit, but wisdom is knowing that it doesn't belong in a fruit salad. I always like that saying. All right, so for point number 1, you ask the user their name. The program asks the user for their name. Another point for the user's name used in all the following prompts. Oh, sorry, that should be 1 point and 0 points. There we go. So 1 point for doing it, right? No points if you missed it. If you sort of had it, again, I'll try and do partial points where I can. The program asks how many guests are coming to the party. The program asks how many slices of pie each guest will eat on average. Right? And then the program asks what kind of pie will be made. And then the program calculates the number of pies required based on the guests and slices. And how many slices? I don't know. I'm bad at words. How many slices each pie has? Sure. I know you can cut pies differently. We're imagining here, okay? Right? Just imagine you can only cut your cherry pie into 6 slices. I don't know. Right? And then the number of pies is a whole number rounded up to the nearest whole number. Rounded up. Right? Don't tell me to make 1.5 pies. Right? Am I getting it there? What am I missing? And then, yeah, that's it. Just those 8. So 8 points. This overall score thing, just ignore it. I'm sorry, I can't get rid of it. So it'll just tell you overall score, and that means nothing.
Did you ever update quiz 1?
Yeah, it should be viewable now, so you can see the questions and answers. Apparently I didn't hit save on a bunch of things. I'm really confused. It should have been changed, but maybe I changed it just for the other class and not for this one. Okay, so that's project 1. Again, the link will make a new repository for you. So you're gonna go through the steps, make that repository, clone it so you have the folder on your computer, and in Netbeans, when you make a new project, put it inside that folder. So every project will have its own folder. We're gonna keep things nice and organized and separate instead of putting them all in one. Right? That make sense? Cool. How I lost the whole description of the other project. That's so weird. The other class is doing pizza. We're doing pie. I was really hungry Tuesday night when I did pizza, but now I want pie. All right, that's all I've got today. So we went over some more examples. Let me make sure those make it out to the GitHub repository. The rest of the day we've got to work on it, practice the other things, read the book. Right? Please read the book. I don't.
It's not bad, honestly.
It's not. I mean, Murrock does a decent job of making a readable book. It's still a textbook. Like, it's not fun to read, but, you know, this is more chapter 2 examples. We should be in pretty good shape. So Wednesday we'll pick up with chapter 3. And I think I've got the quiz. Did I put the quiz out there for you already? For the chapter 2 quiz? I did. Okay, so the chapter 2 quiz, we've got a week from today, 11:59 p.m. to finish it. And again, it's just like the chapter 1 quiz, 10 questions, open book, open notes. They should be free points. Right? You can go find all the answers in the text for them. And if it grades you wrong on a short answer, just let me know, right, what the question was, what your answer was. It messes things up if you don't have like every letter correct for those short answers. They're not perfect. Yeah.
That's what I'm going to see for mine.
Yeah. Yeah, or just see me after class, or shoot me a message. Yeah. Yeah, so just you see me after class or shoot me an email. I'm happy to go recorrect those for you folks. Yeah. It'll take it late. So D2L, I don't close them out in D2L. Yeah, I mean, that happens. Yeah, that's our first one. That's okay. Yeah. All right, take it now. So it'll flag it as late, but don't worry about that in D2L. I haven't gone over any answers in class. So like, the only thing you're missing out is just not having done it on time. So like, try not to again, but yeah, no problem. No problem. All right, so we'll call that a day with the